So this question asks us to consider the function f of x equals negative 2x cubed plus 30x squared minus 54x plus 3. It asks us to find the critical numbers of this function. It asks us to determine on each interval whether the function f of x is increasing or decreasing. It asks us to find the inflection point, meaning where does the function change concavity. And it also asks us to find on the intervals which ones are concave up and which ones are concave down. So we're going to be using the first derivative test, the second derivative test, and also the concavity test and the increasing/decreasing test. So beginning with part A, finding the critical numbers means where does the graph change from increasing to decreasing? The way we find those critical numbers is by differentiating the function and then setting it equal to 0 and then solving for x. So to differentiate this function, we say that negative 2 times 3 times x to the 3 minus 1 plus 30 times 2 times x to the 2 minus 1 minus 54 times x to the 1 minus 1, and then 3 is already times x to the 0th power, so that term just goes away. So f prime of x is negative 6x squared plus 60x minus 54. Now we want to set this equation equal to 0 and then solve the quadratic equation. So let's divide the whole thing by negative 6. So we have x squared minus 10x plus 9 equals 0. This is easily factorable into x minus 1 times x minus 9 equals 0. And when we see that we have to set x to two numbers, those two numbers are going to be a and b, the critical numbers. X equals 1 and x equals 9 will make this equation equal to 0. So that's a and b, the critical numbers. Part 2 says, for each of the following intervals, tell whether f of x is increasing or decreasing. So the way we do this is by making a number line, putting our two critical points on there, 9 and 1. Now we plug a number that's less than 1, a number that's between 1 and 9, and a number that's greater than 9 into f prime of x in order to find out whether f prime of x is negative or positive. So when we pick a number that's less than 1, let's say we plug in 0 into f prime of x. So, f prime of 0 is going to be 0 plus is going to be negative 6 times 0 is going squared plus 60 times 0 minus 54 is negative 54, so it's negative. Then we'll pick a number between 1 and 9, so let's just pick 3. F prime of 3 equals negative 6 times 3 squared plus 60 times 3 minus 54. That's going to equal 9 times negative 6 is negative 54. Negative 54 is going to be, times 2, is going to be negative 108 plus 180 is 72, I think. So it's positive. Now we'll pick a number that's greater than 9. So we'll do 10. F prime of 10, oops, that's really bad. F prime of 10 equals negative 6 times 10 squared plus 60 times 10 minus 54. And this is also going to be, let's see, so we have negative 60 negative 6 times 10 squared is negative 600, plus 60 times 10 is 600, so those go to 0, and then we're left with negative 54. So this is negative, meaning this graph goes from decreasing to increasing back down to decreasing. 1 and 9 are the points where there is either a minimum or a maximum. So on the interval negative infinity to 1, it is decreasing. On the interval, union between 1 and 9, the function is increasing. Union between 9 and infinity, the function is decreasing. Problem number part 3 says that f of x has an inflection point at x equals c, and we have to find c. So we'll differentiate the function one more time. F double prime of x is equal to negative 6 times 2 is negative 12x, and then the derivative of 60x is 60. The inflection point is the point that makes this equation equal to 0. So we'll set this equal to 0 and solve for x. 12x equals 60, which means x equals 5. So when we plug in 5 into this equation right here, it's going to make it equal to 0, and that's also going to be the point at which the graph changes from concave up to concave down. So that is the inflection point. And to find the intervals where it's concave up and concave down, we do another number line here. We have the inflection point 5 in the middle, and then we pick a point that's less than 5 and greater than 5, and then we plug those into f double prime of x. So let's pick f double prime of 0 equals negative 12 times 0 is positive 60, which is positive. So that is concave up. If we pick a point greater than 5, we'll do 6. We have f double prime of 6 equals negative 12 times 6 is negative 72, plus 60 is going to be negative 12. So that is going to be concave down. And that means that the intervals of concave up and concave down, concave up is going to equal negative infinity to 5, and then concave down is going to equal 5 to infinity.